Hello, students. Good morning, good afternoon, good evening. Kingdom Animalia series. Running through the Kingdom Animalia series. Previously, we learned the chart, and now we started analyzing the chart. Kingdom Animalia classified into two subkingdoms: subkingdom Parajuva, subkingdom Eumetajuva. Subkingdom Eumetajuva further classified into grade radiata or diploblastica, grade radiata or diploblastica, grade bilateria or triploblastica. So, in the previous class, we are completed diploblastica and triploblastica. As I said to you, if two germ layers are present, ectoderm and endoderm, diploblastica. If three germ layers are present, ectoderm, endoderm, and mesoderm, triploblastica, isn't it? Today, let us see about radiata and bilateria. This is based on the symmetry. Animals are having radial symmetry, we call radiata. Animals with bilateral symmetry are joined in the bilateria. Okay, so let's go on through these. What is symmetry? First of all, before to go to the radial and bilateral symmetry, you should know what is symmetry. What is symmetry? Geometrical design of body parts is said to be symmetry. What is symmetry? Geometrical design. Geometrical design of body parts is said to be symmetry. Geometrical design of body parts. What is geometrical design? Now I am showing here that if organ is single, that is above on the line, we drawn an imaginary line in the center of human being itself to understand this pattern, this process. Then organ, if it is single, that is above on the axis, that is above on the line. If organs are paired, either sides of the axis equidistantly arranged. Means simply I am saying that this is the line, and organ, if it is single, we are talking about the nose, that is above on the line, isn't it? I draw an imaginary line from the middle of the body. So from paired structures like ears are paired, isn't it? Let us see. From this line, the distance between from here to here is equal to the distance between here to here. We call equidistantly arranged. Okay, single on above the axis and paired structures are going to be on either sides of the axis. So, this is called a design, a pattern. The human being itself having a design. Let me draw you for once again. As I said to you, this is the human being, and let's draw an imaginary line. So, as I said to you that single organ is above on the axis. If they are paired, either sides of the axis equidistantly from the middle line. What is this middle line? That will come to know when I start symmetry. Just we should understand what is geometrical design of body part. So, there is a geometrical design. Organisms are having geometrical design of body parts. You may call them as symmetrical animals. So, symmetry basically we have two types: radial and bilateral symmetry. Radial symmetry and bilateral symmetry. We call them as, based on their symmetry, they have grade radiata, grade bilateria. Let us see bilateral symmetry. Any symmetry, whatever the symmetry it is, any symmetry, first of all, we need to recognize principal axis. What is axis? Might have learned over in mathematics. Axis means a imaginary line drawn between one point to the another point is said to be axis, isn't it? So, we are talking about principal axis. What is principal axis? An imaginary straight line drawn between one midpoint to the another midpoint. In our biological terms, simply we can say the line which I need to draw here, I should draw here, that should divide my body into exact equal halves, that you can call principal axis. Means here I draw a line here in the center of the body which divides the body into two exact equal halves. We call it as principal axis. Okay. So, we recognize the principal axis in case of human being, in case of bilaterally symmetrical animal, principal axis can be named as mid sagittal axis. Principal axis can be named as mid sagittal axis. Okay. Mid sagittal axis. Why it is named mid sagittal axis? Why, sir? Why don't you call longitudinal axis? Yeah, if I draw a line like this, I may call longitudinal axis. You need to understand this design, this line three dimensionally. Means here, I am not drawing line like this. I am drawing a line. I am dividing the organism like this, covering the dorsal side to the ventral side like this. Okay. So, three dimensionally you need to understand from the anterior to posterior. This is called anterior and that is posterior. From the anterior to posterior, covering not ventral side, not dorsal side, covering dorso-ventral side. Means here the back and front, I am going to draw a line. It cannot be a line, it cuts the organism, isn't it? So, in that angle, you have to understand this line, two dimensional, it seems to be like a line. But if you understand three dimensionally, so like this, from dorsal to ventral, we drawn a line, we call that line as mid sagittal axis. In bilateral symmetry, the second one we have to see arrangement of body parts. So, arrangement of body parts, previously we have taken example of human being itself, we are having bilateral symmetry. So, single, if it is above on the axis, as I said to you, if the organism is single, that is above on the axis. If organs are paired structure, eyes are paired, isn't it? Ears are paired. So, pair it is either sides of the axis, on either sides of the axis equidistantly arranged, on either sides of the axis equidistantly arranged. Now, finally, definition. Definition, that is, if you cut the organism, through this mid sagittal axis, if you cut the organism, we get two equal lateral halves. Two equal lateral halves. You need to understand this pattern. Means I am cutting the organism through the mid sagittal axis like this. This is one half and this side one half. Equal lateral half. When I cut the organism through the mid sagittal axis, we got two equal lateral halves. This is lateral half, this is another lateral half. So, two equal lateral halves, hence we call the symmetry as bilateral symmetry. Bilateral symmetry. Let me show, they say once again, bilateral symmetry, principal axis is mid sagittal axis. From the anterior to the posterior, covering dorso-ventrally. A line is drawn, we named the line as mid sagittal axis. Next, we need to see the arrangement of body parts. I said if it is single above on the axis, if it is paired on either sides of the axis, if it is paired either sides of the axis equidistantly arranged. And finally, definition. From where we are cutting through the mid sagittal axis, what we get? Two equal lateral half. This is one lateral half, this is another lateral half. This equal lateral half, you may call identical half. The left half is look like right half, isn't it? Or you may call mirror images. We call such kind of symmetry as bilateral symmetry. In only one plane, in this plane only we get the equal halves, this is only one plane. So, definition need to be careful here. Through the mid sagittal axis, if I cut the organism in one plane, this is the only plane, we get two equal lateral halves. Symmetry called bilateral symmetry. Next, radial symmetry. Let's talk about radial symmetry. To understand radial symmetry, we need to go with phylum Coelenterata and Ctenophora. The well-known example I am taking, that is polyp. If I say polyp, you may not understand. If I say medusa, even you may not understand. But by looking toward the shape of the organism, you might have recognized over that is hydra, and that shown medusa is jellyfish. General names in the Coelenterata, we may call them as polyp or medusa. Interesting thing, when we go to the chapter, we will come to understand any organism in the phylum Coelenterata either seems to be in the form of cylindrical like polyp or umbrella like medusa. Any animal you take, either it will be in the polyp form or either it is seen in the form of medusa. Okay, that all will come in the future. Now let us see about the symmetry, radial symmetry. Here it is the mouth. Where mouth present, that place we call oral end. Where mouth is there, that is called oral end. You may call here in the umbrella shape as oral surface. Where it attaches, the place where it attaches, the substratum where it attaches, that place is called aboral end. Aboral end. Axis drawn from the oral end to the aboral end is said to be oroaboral axis. Oroaboral axis. In the polyp form, what is the oroaboral axis? Where mouth present, that is called oral end. Where it attaches, the place, the substratum, we can say aboral end. Axis traveling from the oral end to the aboral end is called oroaboral axis. Okay. Now, let us try to recognize here. Where mouth present, that is oral surface, the closed end is said to be aboral surface. The closed one we call aboral surface. Oral surface, aboral surface, and the axis drawn from the oral surface to the aboral surface should, it's easy to imagine. Umbrella. There is a stick in umbrella. That stick is called oroaboral axis. The stick is said to be oroaboral axis. Okay. So, in the polyp, in the medusa, we recognized the oroaboral axis. Anyone we have to, we can say, you can take polyp or medusa. By future chapter taking into the consideration, I explain both polyp and medusa. But here, the motto to see both of you, to know what is axis. Like bilateral symmetry, mid sagittal axis. Here, what is the axis? What is the axis? Oroaboral axis. What is the axis in radial symmetry? Oroaboral axis. It's very simple. If you take a pen, okay, let's take this. This is hydra. If it is hydra, in the center, the refill is said to be oroaboral axis. Did you understand? This, if it is the pen, the refill in the center can be called as oroaboral axis. If you want to imagine in medusa, if it is umbrella, the stick in the center, that is said to be oroaboral axis. Okay. Now, arrangement of body. Body parts are arranged radially surround these. I can't show here. If I take a transverse section, you can understand. This is the oroaboral axis. Body parts are arranged surround the oroaboral axis. Body parts arranged surround the oroaboral axis. Now, the definition means we have to cut the organism. I am cutting through the oroaboral axis. If I cut the organism like this, like this, like this, I will show you here, like this, like this. through the oroaboral axis, because it is a cylindrical form. Through the oroaboral axis, if I cut the organism in any plane, we get equal halves. Through the oroaboral axis, if I cut the organism in any plane, equal halves. Let me show you in the radial symmetry. First of all, I said we need to recognize the principal axis. What is the principal axis in radial symmetry? Oroaboral axis. Principal axis, oroaboral axis. Okay. What is the principal axis in bilateral symmetry? Bilateral symmetry, principal axis is mid sagittal axis. The principal axis here, mid sagittal axis. In both symmetries, we are seeing arrangement of body parts. Arrangement of body parts. In radial symmetry, I said arranged radially. What is the meaning of radial? Straight line. Arranged radially, that you have to imagine. There is a pen and a center in the refill. Surround the refill like the radial lines. Arranged radially. Straight line. Radial line means straight. Surround. At least in umbrella you can recognize easily. Center stick is there and there are so many spokes, isn't it? When you see the umbrella from inside, you will find so many spokes. That spokes arrangement of body parts. Arranged radially, surround. This is a stick of umbrella. Surround the oroaboral axis. Surround the oroaboral axis. Here, mid sagittal axis. How does the body parts are arranged? I said, if it is single, that is on above the axis. That is on above the axis. If it is paired, paired structures are present on either sides of the axis, we said, isn't it? Paired structures on either sides of axis. Take an example like nose in the center above the axis, ears and eyes either sides of the axis equidistantly arranged. Okay. Now the definition. We said how we define radial symmetry. Through the oroaboral axis, if you cut the organism in any plane, through the oroaboral axis, if you cut the organism in any plane, you get equal halves. Then how we define bilateral symmetry? We itself example for this. If you cut the organism through one plane, what is that plane? Mid sagittal plane, axis itself mid sagittal axis. Through this plane, if we cut the organism, we get two equal lateral halves. Here you need to remember any plane, here only one plane. This is the basics of symmetry, radial symmetry and bilateral symmetry. Little difficult to understand the criteria, the patterns. That is why we ordered this particular, like we made some order, like for any symmetry, first of all you need to see the principal axis, then after we need to go with arrangement of body parts. Text will not give this much comfort to you, then definition. So in that way, if sir I don't understand symmetry, where you don't understand, either principal axis or in the body part arrangement or in the definition. So to separately, if you think in that particular manner, you will understand easily. Let me say once again, radial symmetry, principal axis is just shown to you, that is where mouth present. No need to remember the both, just for future sake I explain. Where mouth present, we said oral end, where it attaches, that is aboral end, axis a line drawn, or you may imagine like there is a pen, refill in the center is oroeboral axis. Okay. Arrangement of body parts. Arrangement of body parts. We said arranged radially. Arranged radially. This is pen. Radially. Straight lines. Arranged radially surround the oroeboral axis. So, based on the symmetry, whatever it is, radial symmetry or bilateral symmetry, we classified the organisms as grade radiata, radial symmetry, grade bilateria, bilateral symmetry. So, the series kingdom Animalia, in the previous class we are completed germ layers, and today we are completed radial symmetry and bilateral symmetry. There is another one, asymmetry. It is very easy to define. What is symmetry? We said geometrical design of body parts is called symmetry. What is asymmetry? What is the meaning of A? A means absent. Anywhere, anywhere in biology. When it comes A, you need to understand A means absent. Okay. Asymmetry means symmetry is absent. What's the problem? What's the problem? You take animals like some sponges. If you cut the organism in any plane, you don't get equal halves because there is no geometrical design in them. Or your well-known amoeba. Amoeba not belongs to our kingdom Animalia, a shapeless animal, isn't it? If you cut the organism from any plane, you don't get equal halves. Such kind we say asymmetry. Animals, some of the sponges of phylum Porifera are asymmetrical. So, for that there are three types of symmetry we can say, but in our classification we used only two. That what is a radiata or diploblastica, said bilateria or triploblastica. These two and these two we are completed. Okay. Time being, we will complete the whole chart. Kingdom Animalia classified into two types, two subkingdoms, that is subkingdom Parajuva, subkingdom Eumetajuva. Subkingdom Eumetajuva further classified into two grades. What are the two grades? Grade radiata, radial symmetry. Now you came to know what is radial symmetry. Diploblastica, in the previous class we are completed. Diploblastica, two germ layers. Bilateria, bilateral symmetry. Triploblastica, three germ layers. Examples: radiata, phylum Nidaria and Ctenophora. Nidaria nothing but Coelenterata. The rest of the phylum, that means phylum Platyhelminthes to Chordata. Phylum Platyhelminthes to Chordata is having what type of symmetry? Bilateral symmetry. The questions are coming, that we will practice the questions also. In the next session, that after the completion of grades of organization, then after the completion of protostomia and heterostomia, after the completion of spiral and radial cleavage, small definitions are coming. As I promised you that every word of the chart will be completed over with explanation. Till the time, I request the students to read the chart, complete the chart. Okay, complete the chart, whole chart. So, the time being, I am coming with individual explanations, individual definitions, all they are available in the notes which is sent to you. So, go through them, and we continue the scenario, we continue the Kingdom Animalia series. As I said to you, in the end you need to practice 150 questions. If you answer 150 questions which are given based on the Kingdom Animalia series, a grand entry into the BIPC. Welcome, welcome future doctors. That I can say if you complete 150 questions. All questions from the chart itself, all questions from the chart. The day one I said about the chart, explained the whole chart, how to read, and then after I started explaining individual issues of the chart. Today we are completed radiata and bilateria. And in the previous class, we are completed diploblastica and triploblastica. We continue the scenario. Thank you.